While FM synthesis is typically associated with metallic or glassy sounds, it's possible to synthesize a wide range of tones and timbres, including traditional wave shapes. In this tutorial, we're going to go over how to make an approximation of a square wave using Grackle. In order to explain how this works, we need to look at harmonics and sidebands. To put it simply, any vibration in a sound that exists above the fundamental frequency is known as an overtone. The fundamental frequency is what our ears perceive as the pitch of a sound. Harmonics are overtones that are integer or whole number multiples of the fundamental frequency, so 2, 3, 5, etc. This is known as the harmonic series. The harmonics and partials of a sound give it its timbre, which is how we can tell the difference between different instruments playing the same note. Let's look at this square wave on a spectrogram. We have the first harmonic here at about 160 Hz, which is the fundamental frequency. Our second harmonic is absent, but at about 500 or so, we have our third harmonic. Our fourth harmonic is absent, our fifth is present, and so on. On the other hand, if we change this to a sawtooth wave, we can see that it includes all the harmonics, while our pulse wave was missing those even harmonics. This is what people mean when they say that a square wave only has odd harmonics, while a sawtooth has all harmonics. Now, let's take a look at how we could synthesize a square wave-like spectrum with Grackle. We have Grackle in cascade mode, so the second modulator is directly modulating the carrier oscillator. If we bring up the depth, we get tones both above and below the fundamental frequency, and outside the harmonic series. These are known as sidebands. However, we want to generate those odd harmonics. We can move the sidebands by bringing the interval up. Now we have a ratio of 16/8, or double the frequency of the carrier. And now you can see the square wave-like harmonic spectra. And then if we go back to our oscilloscope, you can see it looks very much like the square wave. Now if we want to sharpen up those harmonics, we can add our second modulator since we're in cascade mode. If we bring up the depth, we can see the harmonics gain their own sidebands. Bringing up the ratio, we get to 8/8, and our second modulator is the same frequency as the carrier, creating a sawtooth-like spectrum. As we bring up the same ratio as the other modulator, the sidebands start to cancel or reinforce the sidebands until we reach the same ratio as our other modulator. So if we go back to our scope, we can see that it is still similar to a square wave. However, because Grackle's sine waves are not locked to a constant phase, it introduces some additional peaks, creating an effect similar to running a square wave through an all-pass filter. So, that's how you make a square wave. But you can use Grackle to synthesize all manner of different wave shapes. Thanks for watching. Happy patching!